So before we get into the stuff we haven't gotten yet, I wanted to go over example 6 and 7 with you again because it's going to help us with the rest of the notes that we haven't finished yet. So you should already have this done. I just want to review it with you. If you don't have it done, then you can go ahead and write it down as we go. If you lost your notes and are using the extra one I have, you can just watch and then write the rest of the notes down when we get to that last page. Okay? So if you remember last week, we determined the set line symmetry of these different quadrilaterals. And if you remember, a rectangle, and you folded all those different shapes up, we found out that a rectangle only has symmetry right down the middle, both directions, horizontally and vertically, right down the middle. That's the only line symmetry a rectangle has. Okay, so if you fold it along those two lines, it will match up perfectly. We also discovered that a rhombus, the only lines of symmetry a rhombus has is across, from corner to corner. We also call that diagonally. So diagonally, that's the only line of symmetry a rhombus has. And it doesn't matter what type of rhombus, how big or how small, those are the only lines of symmetry it will have. A square, we discovered, has 1, 2, 3, 4 lines of symmetry because all the sides and all the angles are the same. So whether you fold it across or up and down or diagonally, everything's going to match up because everything's the same. Okay? With a rhombus, all the sides are the same, but all the angles aren't. So that's why it only maps up diagonally. A rectangle, all the angles are the same, but not all the sides are the same. So that's why it only maps up when you fold it long ways or short ways. Okay? A parallelogram has absolutely no line symmetry. Just a regular old parallelogram. So when you're told you have a parallelogram, your answer is always no line symmetry. There's no way we can fold that shape and it matches up. Okay? It's because they're opposite. Nothing's really the same. The opposite sides are the same, but not all the sides are the same, and not all the angles are the same. So that's why nothing can really map up with a parallelogram. We also talked about the rotational symmetry of these figures. Again, you might already have this written down. If not, go ahead and write it down. If you lost your notes, just watch, and you'll eventually be able to follow along. And it says in example 7, determine if the following figures have rotational symmetry. If yes, determine the order and the angle of rotation. Well, we discovered that rectangles, let's trace this rectangle, have an order of 2, meaning we can rotate a rectangle 2 times. There's once, back again twice, back to the beginning. We can rotate it 2 times, and it maps up onto itself. Okay? Remember to find the angle of rotation, you just do 360 divided by the order. So 360 divided by 2. And that gives us 180. So the angle of rotation for any rectangle, doesn't matter how big or how small, okay, has an angle of rotation of 180 degrees. We discovered that a rhombus also has an order of 2, meaning we can rotate it 2 times. 1, 2, and it maps up onto itself. Okay? So that means a rhombus is also going to have an angle of rotation of 180 degrees, because 360 divided by 2 is 180. We discovered that a square last week has an order of 4, because we can rotate it 1, 2, 3, and 4 times, and it maps up onto itself. Again, that's because all the angles and sides are the same. So the order is going to match however many sides there are. So to figure out that angle of rotation, we're just going to do 360 divided by the order. 360 divided by 4. And when we do that, we get 90. So the angle of rotation of a square is 90 degrees. And then the last one, the parallelogram. Parallelograms don't have any line symmetry, but they do have rotational symmetry with an order of 2. Again, we can rotate it 1, times, and it matches up. So the angle of rotation is 180 degrees. And again, remember the angle of rotation is the degree of the angle of the rotation. So we rotated it. That was, when it mapped up, that was 180 degrees. Then we rotate it again, that's another 180 degrees. Okay? With a square, I rotate it once, that's 90 degrees. Rotate it again, that's another 90, for a total of 180. Rotate it again, that's another 90, for a total of 270. Rotate it again, that's another 90-degree rotation, for a total of 360. So it's just what each rotation is to get it to map up onto itself. Okay? Now we can take this concept and apply it. So we should all be writing this down by now at number 8. It says a rectangle is graphed below. So this is super important. We have a rectangle. Determine which of the following transformations will map a figure onto itself. Select all of that, apply, meaning we're going to have more than one answer. Okay. So, like those other symmetry problems we did, we just go down our list, okay, and see if that is a line of symmetry for this rectangle. Okay, and remember, rectangles only have 2 lines of symmetry. So if you're circling more than 2 reflection options, you're probably wrong. You have to go back and check. So A, y-axis. So I'm going to highlight the y-axis. Reflection over that. So ask yourself, is that a line of symmetry? And the answer is yes, it is. So because it's a line of symmetry, we can reflect it over that line and it will map up. Okay, it's going right down the middle, up and down. And if you're not sure, just do the reflection. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Yep. And if we do the -4, -3 and reflect it, 4, 1, 2, 3, 4, it matches up. Same thing with the point -4, 3. Move it over. 4, 1, 2, 3, 4. It maps up onto itself. All the corners map up with another corner. We can reflect it over that line and it will map up onto itself. Okay. We take a look at B, reflection over the line y equals x. Okay, so whenever it's y equals x, we start at the mid origin and just go up 1 over 1. Or down 1 over 1. And if you notice when we graph this purple line, that's a diagonal line. And we just talked about diagonal lines are never going to be a line of symmetry for a rectangle unless the rectangle is slanted, then it might. Okay? But that's not going to work. There's no way we can fold that rectangle over that line and it will map up onto itself. That's not a line of symmetry, so it's not an answer. Okay? And if all else fails, just do the reflection. Pick a point. I'll pick 4, 3, reflected over that line. You go up. Since we went up 1, we're going to go left 1. And that's where the point 4, 3 lands. Well, that point 4, 3 did not land on a corner, so it did not map up onto itself. Okay? If we take a look at C, it says a rotation of 90 degrees about the center of the figure. Well, when it's talking about a rotation, you have to figure out, well, what's my angle of rotation? And we said we can rotate a rectangle 2 times, and it will map up onto itself. That's the order. So we just do 360 divided by 2. So this is just a fact you're going to have to remember. All rectangles have rotational symmetry of 180 degrees. Well, 90 is less than 180, so that's not going to work. If we rotate at 90 degrees, it's not going to map up onto itself. But D works. D is a rotation of 180 degrees about the center of the figure, so that is going to be an answer. Okay. E, reflection over y equals x didn't work, so negative x is not going to work. That's going in the opposite direction. Again, that's going to be a diagonal line, and that does not work with rectangles. If we take a look at F, F is saying the x-axis. Which, yes, if you ask yourself, is that a line of symmetry? The answer is yes. It's going right down the middle of that figure. It's a line of symmetry. So if we reflect over that line, it's going to work. If we take a look at the next one, it says a parallelogram is graphed below. Determine which of the following transformations would map the figure onto itself. Select all that apply, which means we might have more than one answer. But what we just talked about, parallelograms have no line symmetry whatsoever. So anything that's talking about a reflection is not going to be an answer. Because if it doesn't have line symmetry, it's not going to be able to reflect over anything. So none of those are going to be answers. Every time you see the word parallelogram, you're going to scratch out anything that's talking about a reflection. Because in order to reflect over a line, it has to have line symmetry, and parallelograms don't. Okay? We also just talked about that the angle of rotation for all parallelograms is 180 degrees. Well, that's less than 180. That's less than 180. So our only answer is D. That is the only answer option. Whenever you're asked to map a parallelogram onto itself, your only answer option is a 180-degree rotation about the center of that parallelogram. Every time. That's always going to be your answer. That's the only type of symmetry a parallelogram has. So it's the only type of transformation that will map onto itself. If we take a look at the last one, we have a rhombus. It's graphed below. Determine which of the following transformations will map the figure onto itself. So the first one's talking about a rotation of 90 degrees about the center of the figure. Well, again, we just talked about a rhombus's angle of rotation is 180 degrees. Okay? So that's less than 180. But this is 180. So we can circle that one. He's saying a reflection over the y-axis. So let's highlight the y-axis and see if that's cutting the figure in half. Looking at that, that is not a line of symmetry. It's not going right down the middle. And if you're unsure, just check the reflection. I'm going to pick W and count. 1, 2, 3. 1, 2, 3. Yeah, W lands right there. Doesn't land on another corner. Not going to work. Oh, we skipped one. Oh, how am I doing? That's way up there. Sorry. That's not going to work. We already circled C. You might be very tempted to circle D because they both have a rotation of 180 degrees. The one's saying about the center of the figure, meaning it's like if you, right now, if you take your pencil and put it right in the middle and hold it down on your paper and turn your paper, the rhombus kind of stays, the figure kind of stays where it's at. It just kind of moves about, right? Now go ahead and move your pencil and put it on the center of the origin. Put your pencil on the origin, because that's what we're turning about when it says about the origin. And then turn your paper. I'm going to turn my graph. If you notice, I don't think that's going to work. Okay, sorry. I'm going to turn this. Nope. That didn't work. I'm sorry. Okay. But if you put your pencil on the origin, if you can tell, the figure is moving about the origin. It's changing quadrants. If we take X, which is 1, 4, and do a 180-degree rotation about the origin, that's where we take no flip, change the sign of both. And then X will land at -1, -4. Well, that didn't map up onto itself. When you're rotating about a figure, that's where it just kind of stays in place. And it's just turning like this. It's not moving anywhere. Okay? It's kind of staying where it's at. It's just rotating about itself. When it says about the origin, that thing's moving to a totally different location. So whenever you're talking about a figure mapping it onto itself, and it's not centered at the origin, that's never going to be an option. It only works if this rhombus was centered at the origin, then yeah, that would work. But the center of the rhombus is right there, which is not the origin. He's saying a reflection across YW. So we look at our diagram. When it says YW, we're going to draw that line from W to Y. And then ask yourself, is that a line of symmetry? And the answer is yes. Remember from the beginning of this video, we talked about from corner to opposite corner is always going to be a line of symmetry for your rhombus. Same thing with xz. We go from x to z. That's also a line of symmetry. It's going from opposite corner to opposite corner. So those will always be the line of symmetry for a rhombus, whether it's in the coordinate plane or not. 180-degree rotation of the center of the figure, and then across the diagonal, so from opposite corner to opposite corner. I think that's the last one. Yes. Okay, so right now, you are going to work on that 4.5 practice, and then tomorrow we'll review a couple problems together, and you'll have a quiz on Wednesday. Just keep that in mind.